Good morning, sirs and madam, ladies and gentlemen. I'm very happy to have an honor of standing here to deliver to you the presentation of my final thesis on applying an energy-saving routing protocol into the wireless sensor network and simulation using the ONET++. The content of my presentation today, after introduction, I will provide the basic concept of the wireless sensor network and discuss the energy in the wireless sensor network. After that, I will introduce the Pegasus routing protocol and the simulation of Pegasus in the ONET++ simulation framework. And the last part is conclusion and future work. In the introduction, I will introduce our research group in wireless sensor network and introduce my work. So we work in a group of 3 students that include Hien Nguyen under the supervision of Ms. Nguyễn Chi, with a big goal of studying the routing protocols and the data aggregation technique in the wireless sensor network and compare the efficiency of them. After completing the final thesis, I accomplished some accomplishment. This is I obtained expansive comprehension of the wireless sensor network. I get the plenty understanding of the wireless sensor network routing protocols, especially Pegasus. I had a handy skill of using ONET++ simulation framework to simulate the network in general and especially the wireless sensor network. And I complete simulating the Pegasus routing protocol in the ONET++ and analyze the efficiency of Pegasus. I also have to face some hardship. This I had to learn ONET++, which is a totally new simulation framework to me from the beginning. So it takes me a long time to get familiar with ONET++ to start simulating a single wireless sensor network. Also faced the difficulty in working with the new protocols with only a few articles in each protocol. So sometimes I have to explore them by myself. And now I will introduce the description and component of the wireless sensor network. So the wireless sensor network is the network of sensors using the wireless communication to observe the events and phenomena in the specified environment. This is the basic components of the wireless sensor network. We see that we have a network field in which we deploy the sensor node. And after collecting the data, the sensor node will convert the data into the digital signature and send to the base station located near the network field. And after that base station will by some means forward the data to the task management center. And this data transmission can be done by internet or satellite. Only the number of queries depend on the energy, while the frequency of query depends on the network administrator, do not depend on the energy. We observe the following aspect: the number of queries, the position of that node, and the time interval between the that node. Okay, so now we'll show you the simulation. So the ONET++ simulation framework will provide 2 windows for each simulation, an animation windows and another windows for printing the result. To start the simulation, the base station will send a location query to each node, and each node will reply with the location informed so that the base station can calculate the furthest node in the network field. And after knowing the furthest node in the network field, the base station will inform the whole network which is the furthest node to start informing the chain. This is the informing message of the furthest node. And we see that the chain formation process must begin. So each node will send a chain formation message to the nearest node of it. and the transformation process is done until all the nodes in the network has joined in the chain. After completing the chain formation, we choose the head by generating the random number in each node and compare to choose the smallest random number. So we see that the head is chosen, the 0, 1. And now the network is informing all the sensors in the network, which is the head. And after that, it will inform the base station. And the base station send a query to the head, and now the data token is being forwarded along the chain to collect the data. After this, the data token will be sent to the base station, and the base station will know the result, which is the average temperature. So we can see the report of the base station here. The report will show out the number of nodes, the maximum temperature, minimum temperature, the position of them, and the average temperature of the whole network. In case of a dead node, the chain will be reviewed. So here we see this is the network after running for a long time. So we see that there are many dead nodes, and if one node dies, the chain will be reviewed and the head will be reselected, and the process is continued by sending the data to the base station. So that is the simulation of Pegasus. And in this simulation, I can watch the energy consumed in each node, and after energy is equal to 0, the node is considered dead. And the whole network is considered dead if there are more than a half sensors in the network die. Okay, here is the simulation results after running the simulation many times and get the average results. We see that with the wireless sensor network applied in the Pegasus, the network lifetime is much longer. The position of that node is quite random, while the direct transmission it dance in the further half. The time interval between the node that is more balanced than the direct transmission. The image shown on the screen is the position of that node in Pegasus applied wireless sensor network in direct transmission. But we see that in the direct transmission, all the nodes in the further half died before the nodes in the nearer half. In this diagram, the horizontal axis is the number of dead nodes, and the vertical axis is the number of rounds counting the dead node. We see that the Pegasus, the blue one, performs much better than the direct transmission, the red one. Now is the conclusion in future work. So we can conclude that the routing protocols can help saving energy in the wireless sensor network. The Pegasus outperforms direct transmission by reducing the amount of data that needs to be transferred, reducing the length of the route that a packet has to travel through, and the network lifetime is lengthened with Pegasus applying in the network. However, there are still some remaining problems. For example, the head is chosen randomly, and the time delay.
Apply a routing protocol into a wireless sensor network to minimize energy consumption using ONES++. About the contents of thesis. This thesis gives written an overview of wireless sensor network as well as its applications in many fields. And it also mentions about the main limitations of wireless sensor network, energy consuming. To recall this
question, we have two different scenario. In my scenario, the sensor are not mobility, so the position of the sensors at the base station is fixed. Yeah. And in the case of the wireless sensor network with the mobile sensors, yes, we have to update the position of the node. But apply effect assist in the wireless sensor network with the mobile node is a totally different story, and we have to start from the beginning again and redesign the routing protocols, because we know that the grading algorithm only works with the fixed node. If the position of the sensor node is changed, so the change will not be optimal as in the beginning. But therefore, applying back assist in the wireless sensor network with a mobile node is a totally different story, and I have to work more to do the research on it.
I have two. The first question is, even if you talk, you would study further for to study the Thesis protocol versus the delay, right? And the time consuming for the finding the chain take time and energy. So can you take a properly measure how, by analyzing or simulation, how to measure the effect of protocol versus the delay? So that's the first question.
So the question is how to analyze the effect
of the protocol into the delay, especially in Pegasus protocol. And the second question is,
so that means the protocol will affect, will cause delay.
Yes, that's possible. But how can you describe or measure of that?
It means because in your project apply protocol, right?
Yeah.
So you explain protocol in the Thesis like this.
But
Explain.
by simulation, can you do it by simulation or by analyzing? By analyzing the place of the protocol?
Yes, we can simulate to measure the delay affected by the protocol, because the network simulation framework or Net++ support measuring the time delay. So we can measure the time and run the route two network, one applying the routing protocols and another not applying the routing protocol, and compare the time, so we can point out the delay affected by the protocol.